All right, this video is going to be on finding the average value of a function. So first, what we want to remember is average rate of change. If you guys recall from like way old school, like Math 1 and before. So we always said that slope, or average rate of change, is y2 minus y1 divided by x2 minus x1. And the way that we could think of this if we have function notation is we could say that our points, instead of being x1, y1, x2, y2, our x coordinate could be a, and then our y coordinate would be whatever you get when you plug a into the function. And then the second point would be a coordinate of b for the x and f of b. So that would give us f of b minus f of a divided by b minus a. And that's going to be similar to what we get when we do an average value of a function. So the average value of a function is going to be, we're going to call this notation, this is f average equals 1 over b minus a times the integral from b to a, f of x dx. And if you can picture how the math works out on this, then we would be evaluating our antiderivative at b minus a, so it would look kind of like the top, f of b minus f of a, and it would be multiplied by this fraction, which has a b minus a in it. So you can see the similarities between these two equations. So a little note for you guys is that in the entire unit we've done on applications of integrals, this is the only part of the unit where I want to see your antiderivative work by hand, where when you are evaluating this integral, you have to do it by hand and you cannot do it in a calculator. So this is the only part. Okay, so let's do a couple examples. So for our first example, we're going to find the average value of f of x equals 1 plus x squared on the interval -1, 2. And again, if you guys remember, it's been a while since we've referenced this, but when you find the area underneath a curve, which is what we're doing because we have integrals, when you find the area under the curve, the function has to be continuous on that interval. And so if we think about this, this is a polynomial function. It's on the interval -1, 2, so it's continuous. That's something that we always really should be checking, but maybe have been forgetting to check as of late. So if they want us to find the average value, then I'm going to write this notation. The average value of my function is 1 over b minus a, so 2 minus -1. And then I have the integral evaluated from a to b of the function. And I can go ahead and show some work here. This is 1/3. My function would be x plus 1/3 x to the third. And that's going to be evaluated from -1 to 2. And then I'm going to go ahead and show all of this work by hand so you guys can remember how we do this. So I plug 2 into the antiderivative, and then I plug 1 into the antiderivative, and those two numbers are being subtracted from each other. I should put a bracket since we have enough parentheses already. So what I have for this first part is that's 2 plus 2 to the third is 8. So 1/3 times 8 would be 8/3. -1 to the third is -1. So 1/3 times -1 is -1/3. So I have here 6/3 plus 8/3 is 14/3 minus -4/3. So I have 1/3 times 14 plus 4 is 18/3. And 18/3 is just 6, right? So we have 1/3 times 6. And that just equals 2. So if you look at this, if we kind of break up the math that we just did, the 1/3 is this part in front. So that's what the 1/3 means. But the integral itself is the part that's just 6. So that means that the area underneath this curve from -1 to 2 is actually a full area of 6. And now we're saying that the average value of that is 2. So one thing we want to consider is, like, what does this 2 mean? So meaning, that's what we want to understand. And what this means is that the height of the rectangle that would have the same area as this overall integral, has the same area as the function over the given interval. So we're going to draw a picture of that in a second, but I'm going to go ahead and write it so we can absorb it. So the height of the rectangle that has the same area as the function over the given interval. Okay, so now that we have it written, remember this was the 1/3 and this was the 6, so the area of 1 plus x squared from -1 to 2 is an area of 6. Now if I think about a rectangle that's got a height of 2 over the same interval, the width of that interval is 3. The rectangle that has a height of 2 and an interval width of 3 is 2 times 3 is 6. So this curve has the same area as this average multiplied by the width of the interval. Okay, so that's what the meaning is. We're going to go ahead and draw a picture of that so that you guys can visualize it a little bit better. So my drawing is not going to be crazy accurate since I don't have graph paper. You can do this on graph paper if you want. So my parabola was x squared plus 1, so it's a parabola that goes shifted up 1. So I drew my first point of my parabola right here, and then I went over 1 up 1, over 1 up 3. And we said we were looking at the area from -1 to 2. And we said that that integral evaluated there had an area of 6. So that's approximately 6 right there. And then if I go in and I make a rectangle that has a height of 2, so there's our height of 2, then that rectangle would have a height of 2 and a width of 3. And so that rectangle would also have an area of 6. So this average, this rectangle that I just drew, has the same area as that curve. All right, so what this means is that we have the integral and then 2 times 3 equals 6, and the 2 right here was that average, and the 3 is the interval, or the b minus a. So what this means is that this is the y value, right? That's the height. There's going to be some x value here so that this specific x value can multiply by that y value and make the same area. And this might remind you of something, hopefully. It's actually the mean value theorem, which we looked at before, but this is for integrals. So before we'd say, if we can find the slope between 2 points, then somewhere on the curve there would be an instantaneous slope that was equal to that average slope. That's what we did before, and now we're going to do the same thing, but we're talking about areas. So we have the actual area of the integral, and then we have the average, and somewhere, because those two things are the same, somewhere on there must be an x value that is the same that would make that work. So the mean value theorem here for integrals is kind of parallel in language and in thought to the mean value theorem that we used for derivatives. So the mean value theorem for integrals says if f is continuous on AB, then there exists some c on AB such that the integral from a to b of the function equals, this is the height, times that x-coordinate or the width. So that was the average height, right? The height of that rectangle, that was the width. And when we do this, we want to be able to solve for c, or f of c, I mean. We want to be able to solve for f of c, so we want to be able to find this average. And the way that we do that is using that formula that I referenced earlier. So 1 over b minus a times the integral so f average, I'm not writing fav, f average is the same as f of c. All right, so our second example is going to be to find the c value, so find that specific x value from number 1. So we know that we already said that that first function was continuous on the interval. That's what makes it so that we can even find the area underneath the curve. It's also what makes it so that the mean value theorem applies to the problem. And so now we can say, well, our f of c equals 2. That's what we found. And so f of c would be x squared plus 1, or you could say c squared plus 1 if you want to keep the variables consistent there. And so we have to solve for x, and that's going to be x squared equals 1, so I can square root. So x equals plus or minus 1, so that means the c value is plus or minus 1. So what that means is that if you look at the original function, f of x equals x squared plus 1, and you plug in positive 1 and you plug in negative 1, you can even see it over here on the graph of what I drew. These are the x values where the average of the function is the exact same as the height of that rectangle. So that's all you're looking for. All right, so we're going to do one more problem to practice that. So we're going to find the average value of f of x equals 1 over x on 1, 3, and the c value where it occurs. So this is not a continuous function, right? If you look at that, it's undefined at 0, but the mean value theorem is going to apply because 0 is not inside the interval. So we're going to say that this applies because it's continuous on 1, 3. And so that means that we can do our formula to find the average, which is 1 over b minus a. And then we have the integral evaluated from 1 to 3 of the function. So it'll be 1/2. If you guys remember, the antiderivative of 1 over x is actually ln x. And this right here is going to be evaluated from 1 to 3. So we have 1/2 of ln 3 minus ln 1. And we want to keep our answer exact, so I don't necessarily want to plug this in and get all the decimals. But if you checked it, ln 1 actually equals 0. So this is just ln 3 minus nothing. So that means that our f of c is ln 3 divided by 2. So the height of this multiplied by a width of 2 equals an area, and whatever that area is exactly the same as this area right here. That's what we just found. So now if we want to find the x values that are on the curve, where the x values correspond with this y value, we just need to take the function and set it equal to that y value to solve for the x values that happen in the same spot. So I can go ahead and cross multiply. So I get 2 equals x times ln 3. And to solve for x, I'm going to go ahead and divide by ln 3. And so that means that my x is 2 over ln 3, or the c value where this happens would be 2 over ln 3. And if you want to check this to make sure that your answer is right, then we could go ahead and just evaluate that integral. So this is checking our answer. So the integral is 1 to 3 of 1 over x dx. And if you do that, we get 1.099. And that should be the same as f of c multiplied by b minus a. So f of c was ln 3 divided by 2. b minus a is 3 minus 1. So 2 and 2 cancel. So that's just ln 3. And that means that we got it right. So those two things should always match up. That's a way that you can kind of check your answers without needing to look at the answer key.